Alright guys, I'm just going to quickly run through optical isomerism as well, because I just did cis, trans and EZ in the video before. I'm now going to do optical isomerism. So there's mainly two types you need to know, especially at A level. And so the first one is to do with carbon. This carbon is chiral. The reason it's chiral, I'll write it there, chiral, as is this one. They're both chiral. The reason it's chiral is because this carbon is bonded to 4 different groups. First group, second group, third group, and the fourth group. I appreciate the numbers probably look a bit weird actually, so I'll get rid of them. But just appreciate that there are 4 different groups bonded to that carbon. The H is different to the Br, which is different to the CH3, which is different to the NH2. They're all different. This is the exact same thing, however, it's a mirror image. And it may look like the same thing. If I was to rotate it, it would look like the same thing. But one thing would change. I think the easiest way is to show you with a molecule. So this is the center carbon on this one. I'm showing this one. That's the center carbon, that's the hydrogen, that's the Br, that's the methyl group, and this is the amine group. This is going away because this is a 3D molecule. It doesn't just exist as like a flat plane. So that is going away from the plane of the paper really. The plane of the paper is like there. So these two are in the plane. That's going away from it. This is coming out towards us. If I was to rotate it to get it to look as if it was like that, I'd have to rotate it like that. And as you can see, the amine group and the H are still in the plane of the paper fine, but the Br is now pointing up. And we know that dashed bonds go downwards. And the methyl group is also pointing downwards, however a wedge is meant to be pointing up. So they're not the same molecule. Once again, I can keep it like that. That is the same as that. But then when I rotate it, it's not the same. There is no way I can rotate this to have this Br pointing down and everything else to line up properly. It doesn't work because they're 2 different molecules. It's like my hands. My hands are mirror images of each other. I can go like that. They're mirror images, but they're non-superimposable. I can't put one over the other. It looks the same because the thumb is different to the pinky, for example. But then if I go like that, there's different planes, because essentially if we imagine it's 3D, like the front of my hand is different to the back. It just doesn't work. They're 2 different objects, as is this and that. They're 2 different things. This means that they are enantiomers. And so as they're enantiomers, that means that they're not the same molecule. I can then move on to more complex, quite literally, complex optical isomers. So for example, this is probably the best way of showing it. This is just an iron 2 plus iron, and then it's bonded to 3 1,2 diamino ethane molecules. This is the first one, this is the second, this is the third. But as you can see, because these dashes and these wedges, they are coming out and into the plane. It's not 2D, it's not a flat molecule. But the way to draw the mirror image of it, so you go like that, that, that. Keep that the same. For this one, you have to come around the opposite side. So this is quite hard to draw, to be fair. And then finally, just draw the last one in. There's nowhere else it can go. And that is a mirror image. Those 2 molecules are not the same. I'm not going to draw the molecule, but imagine it's the same as like this example, where no matter how I rotate that one, it will never look like that, because they're literally mirror images. They do not function the same. Hopefully that helps.